Hi, everyone. In this lecture, I want to start to get into the driver technology, safety technology in the vehicle, and by looking at intelligent transportation systems and some driver assistant technology. And this is going to be somewhat old in terms of the current, state of affairs. And I've kind of left this like this because I think this is a very popular topic for a paper. The paper for the course, if you want to do it, I think looking at newer things like in this, I'm not going to talk about Tesla at all. There's so much we could talk about there, research that's been done on Waymo and Tesla. So I'm going to kind of leave that open for people to do as their own paper topic if they're interested. But over the last few lectures, we've seen there's a lot of problems with drivers, right? We have perceptual problems. Sometimes we see things below threshold. We make decision problems, or we're distracted. We get angry. We want risk, right? So there's a lot of problems there with the driver. But really, as I tried to point out in that last episode, last lecture, constantly blaming the driver for accidents, saying it's driver error, driver error, driver error is not really productive at all, right? It doesn't help anything. It really points to the fact that maybe the problem isn't unsafe drivers. It's the fact that we designed an unsafe system, right? We've designed a system where we know that people can't pay attention very well all the time. And we've designed a system where that causes accidents, right? We know people make errors. We know people make decision making errors. We need to design a system that takes that into account, right? This is kind of a basic principle of good design. Example I like to give is Outlook or email programs that, right? If people keep sending an email where it says see the attached file and they forget to attach to something, right? You have a poorly designed piece of software, right? If people keep making the same error, you need to take that into account and redesign your software, right? Make it pop up something when it sees the word attached and you haven't attached something, that many of them have now. Okay. So we know that people make errors, people have limitations. We need to take that into account. So how can we make things safer, right? How can we deal with these issues? Well, there's a couple. So, and as I said, we could put it this way, it's not normal to be consistently alert and attentive all the time, right? And accurately picking up information and not emotional and not risky. That's not normal human behavior, right? If we put in our head in the sand and pretend it is, then we're going to lead to accidents. So we need to change something about the way the system is designed, right? So how could we do that, right? There's a bunch of different things we could do, right? There's at the very extremes, right? We could make driving not a right. We can make it a privilege, right? We could make it so the driving test was so extreme, the only people that are really skillful can get it, right? This is essentially what they do in aviation, right? Not anybody can just become a pilot. You have to go through hours and hours of training and pass difficult tests. We could make driving like that and would reduce traffic, right? There'd be less cars on the road, but people would be really ticked off because, right, driving is essential for getting around and in our society. And we're going to talk about that in elderly drivers when we get to that point, because taking a driver's license away is a serious choice, right? You're going to change their life dramatically. Okay. The other end of the thing, kind of a more moderate solution, is we could have better driver training, right? We could everyone before they get their license, you're welcome to it, but you have to go through one of those closed course skilled driver training things. We have one of these not too far from our campus here in Poly. There's a big driver training thing where they do police things. We can make everyone have to go through that first before they get a license. Again, that's probably not practical. Probably not people are going to go for the cost and the time involved, right? The other two are kind of automation, technology ones, right? An extreme one that's becoming less and less extreme. It's still, we'll see when we get to automation. It's actually still quite a ways away. Is making driving either fully or partially automated, right? So the vehicle drives itself. The one that's kind of now, and it's getting there, is what we lump into driver assistance, where the car and you and the car drive together, right? So we put things on highways and in the vehicles to compensate for these normal human deficiencies, right? So, for example, we can make driving less demanding. We can use cruise control, lane, and all these things to help support. Okay. So this is kind of, one of the ideas that people have put forth with these is to combine them, right? One of the things we could do is have you drive. If the car detects something like you're going to hit another vehicle, it gives you a warning first, and we're going to talk about driver warnings next time. If you don't respond to the warning, it's going to start helping you control. So maybe it will help push you back into the lane if you're starting to go out of the lane. If you're still not controlling, this is before you hit, it's going to take full control over and become fully automatic and break the car or turn you out of the lane. So those kind of ideas have been around for quite a while. Okay. But intelligent transportation systems, the idea is it's this combination of automation and driver assistance. Okay. Sometimes we call these smart cars or smart roles. Okay. One of the things we're going to see when we get into automation, and we'll visit this from when we get to aviation as well. Okay, obviously, automation has been automatic pilots. Autopilot has been around for much longer than auto driving. And what you're going to see, the really important point we want to make here is that automation doesn't remove a human being from the loop. It changes their role, right? So think about driving your car versus an automated car, right? Like a Tesla in fully auto mode. What you're changing is from you being the active controller to you being more of a monitor and a supervisor, right? Monitoring, making sure everything's okay. Okay. And there's been several optimistic advantages if we could fully automate things, 50% reduction in fatalities and things and so on. Okay. Automated driving obviously is hands-free. We already have a lot of built-in automations that people don't think about, right? Airbags and anti-lock brakes is kind of automated driving, right? Anti-lock brakes is when you hit on the brakes, it actually changes the way the car stops. Instead, it's like you tapping the brakes without actually doing it. There's also adaptive cruise control, which I've talked about. A lot of cars have. There's steering control, right? So a lot of cars have variable resistance. So if you're going out of the lane, it actually applies force to get you back in there, right? So it's not taking over full control. It's just assisting you. Okay. There's obviously safety and economic benefits. If we could fully automate driving, either through technology like a Tesla or putting, for example, little hooks on the road that pulled you along, it would be way more efficient and environmentally friendly because cars could travel like 1 foot from each other, which is more aerodynamic, things like that. Okay. We could automatically detect and enforce traffic laws without having to have police involved. And we can do communications between cars, which would be safer, right? I could send a signal to your car telling you I'm going to turn, right? Instead of relying on the driver to detect a turn signal. Okay. Um, some of the more developed ones of these, what we talked a bit about, is adaptive cruise control or intelligent cruise control. As I think I talked about before, the idea here is we're not just controlling the distance between you and the other vehicle. We're actually controlling the time headway, right? So you're staying 2 seconds behind the car in front. In a Tesla, there's a little slider that you actually choose this. So you can choose to be a bit closer, a bit forward. It does it in car lengths, I believe. So the idea is it's going to adjust your speed based on the behavior of the car. So it's adding some assistance to you, car following assistance, by kind of controlling your speed. In a true adaptive cruise control, it's only controlling speed. You still have to keep the car in the lane, obviously, and steer. Okay. This is done by a variety of different things. There's lasers, radar, LiDAR. There's a bunch of different ways you can do this. Things like Tesla now are moving to a full computer vision solution, which we're going to talk about in a second, where the cameras are detecting the other vehicles instead of lasers or something like that. Okay. Automated driving, obviously, that's now available. Depending, this number is very old. There are some technological problems. Most people are aware, if you kind of follow, there's been some incidents with Tesla. There's certain ones that seem to be weird where they have the failure to detect stopped ambulances was a weird one. So there's some problems relative to the amount of driving accidents involving full regular driving. They're pretty low. But the most common type of one, and we're going to talk about this in a little bit when we get to driver warnings, is when the automation requires the driver to jump back in, right? So imagine you're driving a Tesla and you come into a very difficult construction area where it's hard for the Tesla to know where the lane lines are and things like that. It asks for your help. The problem can be it's sometimes called the takeover problem and the handover problem. The driver doesn't know what's going on, right? They haven't been paying attention and they have to jump back in. Okay. Inter-vehicle communication, there's lots of different ways you can do that, as I mentioned. Okay. So for lateral control, there's also, keeping you in the lane. There, as I said, you can do this with radar. Um, we could do this with camera. Problems can come with this when we have weather issues. It becomes hard to detect the lane lines because of visibility. Okay, so things like that. So these kind of camera technologies, laser tech, are advantages because we don't have to change the roadway. Right. One kind of basic technology, smart technology that's been around on roads for a long time, depending on what state you're in, is the little reflectors right on the lane edge. Those not only help you see, they also, when you hit them, you get immediate vibration feedback telling you're going out of the lane, right? So that's an example of a change to the road to make people safer. These are mostly changed to the cars, which are much less expensive. Computer vision, obviously, this is really old. If you look at a Tesla, it's way different. Um, this is computer vision is actually pulling out and detecting from the video itself without using any you can combine it with lidar or radar, but detecting the presence of cars and identifying cars, which has gotten consistently better over and over the years. We're getting better at better. There's still some times that it doesn't work so well. One of the really challenges, and I worked on this several years ago, is identifying pedestrians, right? It's very hard to do that. And there's, if you Google, if you want something fun, Google Tesla driving through a cemetery, and you'll see some examples of why challenges in identifying pedestrians and what people can make of it. So have a look at that. Okay. There used to be some issues kind of detecting lane lines. As I said, these are getting better and better. There's been some more crazy ideas proposed, like, as I said, putting little like rails in the road, putting magnets in the road to actually pull you along. Obviously, those are way more expensive. They would be safer. You wouldn't have these errors, but they'd be much more expensive. Okay. So these are kind of some of the kind of different ideas. Okay. Um, the idea here is that, with some of these things, is that the idea that we can, we've been talking about this hierarchy of driving skills that we can break away and we can take some of them away from you, right? And have you do otherwise. So if we can take steering and headway control away from the driver, right, that should give you more attention to route selection, hazard perception, like we were talking about last time. If you don't need to control, remember we saw this with the novice drivers, right? If you take away the need to control, it gives you more attention available to put on the road and see things. So that's kind of the idea behind it. Okay. Partially this works, right? This assumption. Partially it doesn't, right? Because the the assumption really is based on the idea that you don't need to monitor the automation, right? The assistance, where that's not really true, right? It does take some attentional resources to make sure that you are following safely, you are staying in the lane. So we need to take into account these factors. Okay. Plus, there's multiple issues, right? There's multiple other issues people really don't consider when they talk about, they envision a world with full of Teslas or other EVs. You know, Obviously they're fairly expensive right now. Getting everyone one, how are automated vehicles and regular vehicles going to work together? How much trust do people have? People actually like driving, as we talked about. They like the risk perception with sensation seeking. Do they want to give up full control? The issue of automation failures. Um, we get a loss of skill, right? Will you lose skill at being able to drive it, and having to jump in? The other thing is, getting cars to drive like that's comfortable for the human. So a car can drive around a curve. Automatic vehicle can drive around a curve much faster than you might like, right? Things like that. So there can be a lot of issues. Okay. Um, it's also one of the things a lot of people are doing now is and we'll get to this in aviation and really heavily. It's led to some severe plane crashes, is we're trying to avoid automation, what are called automation surprises, where the automation does something that you wouldn't do as the driver, right? Something unpredictable, right? They're using different information, different control laws. So what a lot of effort is being put into is actually doing research where they have an automation running alongside a real driver. So it's not actually doing anything, but it's deciding what it would have done, and they compare it to what the human driver actually does to try to avoid these kind of things, because that can be a big issue. As I said, in aviation, we'll really get into that. Okay. One of the big things that we worry about with automation and when we do assistance is the driver is going to lose what we call, done this term a few times already in the course, situational awareness, right? The knowledge of what's going on. As we talked about last time, one of the things that seems to separate experienced drivers from less ones is experienced drivers just look around more, they check their mirrors more, so they have knowledge of what the situation is. When something dangerous happens, they have this knowledge they can put into doing a maneuver, right? They know, can I go into the other lane because they know a car is there. Okay. When it's very unlikely that if you have a full automated vehicle, right, you're just going to sit there and stare out the window and try to keep tabs of what's going on and have good situational awareness, right? It's much more likely you're going to go on your phone and watch a video, go on social media, daydream, sleep, right? So if the car needs you to step in, the likelihood you know what's going on all around you and have good situational awareness is pretty low, right? And we'll see this in aviation accidents. Um, there's been a bunch of studies, for example, at the University of Iowa, looking at kind of questioning people's, will they accept smaller gaps that were more efficient, things like that. And you get kind of varying. It's really, I find a lot of the automation questionnaire research hard because I don't think people really understand it until you actually get in an automated vehicle. It's hard really to make any of these kind of assessments, I think, right? And you can look at these in the slides. There's a bunch of kind of questions. So that's kind of automation, intelligent driver. The other kind of end of the spectrum we've already talked a little bit about is driver assistance, right? Where we want to supplement perception rather than take control of the vehicle. So we can there's some cars that use night vision technology to enhance the images the driver sees at the car. We can warn you by redirect your attention when we know your attention's not on the road, and it should be. We can redirect it with a warning. Okay, warnings are a challenge, and we're going to get into. I'll do a whole lecture on designing driver warnings because there's a lot of human factors issues associated with it. There's adaptive, other kind of driver assistance that people have put it forth. There's a bunch of them over the years. Adaptive headlights that change their spread, night vision enhancement, getting rid of the pillars and trying to increase the driver's view. Blind spot warnings. This is something I have in my new vehicle that I really love. In the mirror, right? When there's a car in my blind spot, there's a little orange LED image of a vehicle that comes on in my mirror, right? So it's very innocuous, like it doesn't distract me. But when I look at my mirror, if I'm going to change lanes, it's sitting there telling me there's a car there. Augmented brake lights. This is something I mentioned a few lectures ago. Brake lights that actually tell you how hard the driver's braking. Impairment monitoring, with DOI, there's a bunch of different examples of that. So we can do, there's a bunch of different things we can do. Night vision enhancement, as I said, detection of animals, right? There's a lot of work in states like Montana, the northern states, where there's real problems with drivers hitting deer and bears and other things. There's been work on, can we design things to detect these better? Okay. Um, there's some examples, right? Jaguar has been one of the very early ones to try to enhance visibility. Okay, creating head-up displays, something projected onto your windshield, and we'll talk about a little bit about this later on. I mentioned some of the stability systems like anti-lock braking, traction control. You can really think of those. These are driver assistance. There's other ones that can detect through the kind of force from your tires, whether it's slippery or icy, four-wheel braking, powered. So there's a lot of different things we can do and have been done. Okay, stability systems. BMW is another one that's done a lot of their iDrive system. Another way that we've kind of gone in a roundabout way to do this is give drivers in the infotainment unit, the thing in the middle of your car, try to give them the ability to text via voice, hear their text, those kind of things. So accepting the fact that people want to use social media and text, but giving them safer ways to do it. That's another type of driver assistance. There's also ones I worked on this many years ago. There's systems that people have developed to detect when you get drowsy, right? By having a camera that looks kind of at your eyelids or you're blinking, to detect where you look around to detect drowsiness and drunkenness, right? So drowsiness would give you kind of some warning to alert you, obviously. There's also kind of workload managers, right? That kind of measure the different with tasks involved in the hierarchy and so on. So there's lots of different types of ways we've done this. Um, Driver assistance is really almost all cars have some form of it now. It's not everyone has the cruise control and the lane departure, but as I mentioned, the anti-lock brakes. This was a long time ago. I made this slide. Collision and lane departing warnings are obviously here. Backup monitoring, right? So all these are kind of driver assistance. There's also ones that warn you if you're heading into a curve too quickly. So there's a lot of different things. These nice vision enhancement. So there's still a lot of work going on in this area, and it's predicted. This was a long time ago before we really got into automation, but this is a kind of aggressive prediction that by 2030, all vehicles will have some really high advanced kind of assistant intelligent transportation systems. Okay. Um, what we're going to get into next time in the Lex Couple is kind of the human factors issues of putting this all together, right? If we're going to warn you or we're going to take control, how should we do it? If we're going to hand back control, how should we do it? So we're going to get into some of these issues with our next lectures. Okay. Another thing that I worked on a while ago is actually trying to predict what a driver is going to do before they do it. Right. So, for example, trying to predict when you're going to change lanes just by observing where you look and how you hold the steering wheel. If I could do that, then I could give you a warning before you crash into that car in the blind spot. Right. So giving you a timely warning. Obviously, we're going to talk about warnings. As I said, we don't want to warn you all the time. We don't want to warn you when you don't really need a warning, or you're going to start to ignore them or turn them off. So that's a really important initiative as well. Okay. And this is something, as I said, people and when I worked with Nissan, this group did trying to recognize drivers' intentions just from where they looked. And what they found was that they could, so this was when you be starting to drive movements, after about 2 seconds, they could recognize what you're doing about 90% accuracy. Okay. And depending on the different movements. So this was a long time ago and we've gotten much, much better. So recognizing what you're going to do before you're going to do it. Okay, so that's it for this lecture, first lecture on driver assistance and intelligent transportation systems. We're going to get into more specifics of driver warnings and automation in future lectures. Thank you.